Hello everyone and welcome to my channel. Today we are diving into a classic LeetCode problem, find the difference. Let's begin by understanding the problem. We are given two streams, S and T, where T is generated by randomly shuffling S and adding one extra letter at a random position. Our task is to find that extra letter. Now you might think of iterating through both streams and checking the count of each character, but that could be tedious and time-consuming. Lucky for us, Python's collections module comes to the rescue with its counter class. Let's take a closer look at the code. Here we start by importing the counter class from the collections module. The collections module is a built-in Python module that provides specialized data structures that are not available in the core Python collections, like lists, tuples, and dictionaries. One of the useful classes in the collections module is counter. Counter is a class within the collections module that is used to count the occurrences of elements in an iterable, typically used with sequences like strings, lists, or tuples. It creates a dictionary-like object where elements are stored as keys and their counts are stored as values. Then we define a class solution with a method find the difference. This structure is common when dealing with LeetCode problems. Next, we create two counters, count1 and count2, for streams S and T, respectively. And these counters will count the occurrences of each character in the respective streams. And we calculate count3 as the difference between count2 and count1. And this effectively gives us the character that was added to T, but is not present in S. Finally, we loop through the keys of count3 and return the character. Since there's only one character in count3, this loop will execute only once. The most time-consuming part of this solution is constructing the counters for both strings S and T. Constructing a counter for a string takes big O of n time, where n is the length of the string. The loop through the keys of count3 executes only once since there's only one extra character in T compared to S. Therefore, it takes a big O of 1 time. So the overall time complexity is dominated by the counter construction step, which is big O of n, where n is the length of the longer string, which is T in our case. So as of space complexity, we are using three counters in this solution. Count1 for string S, count2 for string T, and count3 to store the difference between count2 and count1. Each counter stores character counts. So they take up space proportional to the number of unique characters in their respective strings. In the worst case, where both S and T contain all lowercase English letters, each counter could have up to 26 unique characters, which is from A to Z. Therefore, the space complexity for the counters is big O of 26, which is also big O of 1. Additionally, there are some constant space overheads for the solution class and other variables, but these are also considered constant in terms of space complexity. So overall, the space complexity of this solution is big O of 1, since the space usage does not grow with the input size. It is constant because it's primarily determined by the number of unique characters in the alphabet, which is a fixed size. Okay, that's our first solution. Now we will explore a different approach that simplifies the code even further. The essence of this solution lies in the elegant use of Python's counter and set operations. Let's break down the code. We define the solution class and its method to find the difference, just like before. And here's where the magic happens. We calculated the difference between two counters using the hyphen operator. And this operation effectively subtracts the character counts of S from T, leaving only the added character and its count. We then loop through the keys of this resulting counter using the for key in loop. Since there's only one key, which is the added character, so this loop will execute only once. Inside the loop, we return the key, and which is the added character that we are searching for. The time and space complexities for this alternative solution are identical to the previous one. Constructing the counters takes big O of n time, where n is the length of the longer string t, and the loop through the keys takes big O of 1 time. Therefore, the overall time complexity is big O of n. The space complexity is big O of 1 because we are using counters and sets to store character counts, and the space usage doesn't grow with the input size. And there you have it. We have successfully solved the find the difference problem using this elegant and concise alternative solution. Python's counter and set operations make it possible to achieve the same result, which with fewer lines of code. And remember that in programming, there's often more than one way to tackle a problem. Exploring different solutions like this one not only enhances your problem-solving skills, but also broadens your Python toolkit. I hope you found this tutorial helpful. If you did, please like and subscribe for more LeetCode tutorials. If you have any questions or suggestions, please leave them in the comments below. Happy coding and thanks for watching. Goodbye.